So today we're going to be looking at section 2 of chapter 12, which is the surface area of prisms and cylinders. So just a little bit of vocabulary. A prism is always going to be a polyhedron with two congruent faces called bases that lie in parallel planes. So it's important to note that the prism doesn't necessarily have to sit on its base, but its bases must always lie in parallel planes. So here we have a hexagonal prism. The base is a hexagon, and remember that prisms are always named and classified by their bases. And we can see that they lie in parallel planes. The lateral face of a prism is going to be the faces other than the bases, and there are going to be parallelograms formed by connecting the corresponding vertices of the bases. So we see here that we have a lateral face. The lateral edges will be segments connecting these vertices. So it's just going to be the edges that we learned about in section 1. So what is surface area? Surface area by definition is the sum of the area of all of a shape's faces, whereas lateral area is going to be the sum of the areas of just the lateral faces. So lateral area does not include bases. So what if I'm given a cube and I'm asked to find the surface area if the side length is 6 inches? Well, I know that a cube is made up of 6 faces, and they're all congruent. And I also know that the area of one face is going to be 6 inches times 6 inches, which equals 36 inches squared. Okay? So then, how do I find the surface area? Well, I have to multiply my number of sides times the area of one side, and I get that it's equal to 216 inches squared. And this makes sense because we're looking for a surface area. So if we're looking for a surface area, our units are still going to be square. If you're looking for an area, you will always end up with square units. But what if the problem asks me to find it in square feet? Well, now I'm going to have to use some dimensional analysis to make sure that I convert my units correctly. So I have 216 inch times inch, and I have to multiply that by 1 foot over 12 inches because there are 12 inches in a foot. But this only cancels one of my inches. I have to multiply it by that same number again to get rid of my second inch unit. So when I multiply these out, I get that the surface area of this cube is 1.5 feet squared. Remember this number. So we actually have two different types of prisms. We have right prisms and oblique prisms. So just like when we were finding the area of a triangle, a parallelogram, a trapezoid, our height is always going to be perpendicular to our bases, except for instead of being perpendicular to a line, they're now perpendicular to a plane because we're in 3D. In a right prism, each lateral edge is perpendicular to both bases. So we look over here and we see that this is perpendicular and this is perpendicular. So I have a right, in this case, rectangular prism. In an oblique prism, the prism with lateral edges are not perpendicular to bases. So I have a lateral edge and I have a height, and my height is perpendicular to my base, but my lateral edge is not. So in a right prism, your height and your lateral edges will be the same measurement. In an oblique prism, your lateral edge and your height will not have the same measurement. So how do we find the surface area of a right prism? Well, we use this equation. So we know that the surface area equals 2 times capital B plus P times H, where capital B is the area of a base. So little b is the length of a base, capital B is the area of a base, P is the perimeter, and H is the height. So I want to find the surface area of the right prism shown here. Well, I know that it's a triangular prism because these triangles are my bases that lie in parallel planes. So I know from my equation that my surface area equals 2 times the area of a base plus P, the perimeter of a base, times H. Well, what do I already know? I know that the perimeter of my base is 6 times 3, because it's an equilateral triangle, so it's going to be 18 inches. And I know that my height is going to be 8 inches, because it's going to be perpendicular to my bases. So I'm looking for the surface area, and I know the perimeter, and I know the height. So I need to find the area of my base, my capital B. So the easiest way to do this is I have an equilateral triangle. So I know that all the angles are equal at 60 degrees. I can drop a perpendicular bisector, at which point I have a 30, 60, 90. So I know that the height of this triangle is 3 root 3. Go review your special right triangles if you didn't remember this. I also know that the area of a triangle equals 1/2 base times height. So it's going to be 1/2 times 6 inches times 3 root 3 inches. So therefore my height, or my area of my triangle, is 9 root 3 inches squared. And so this is actually, for the case of my prism, going to be capital B. So now all I do is substitute my values in, and I know that the surface area is 2 times 9 root 3 inches squared plus 18 inches times 8 inches. So that's 18 root 3 inches squared plus 144 inches squared. And that's going to be approximately 175.2 inches squared for the surface area of this right prism. So now you need to find the surface area of a right rectangular prism with height 5 feet, length 11 feet, and width 4 feet. Make sure that you draw a model of this picture. So what is a cylinder? A cylinder is going to be a solid with congruent circular bases that lie in parallel planes. So our bases, once again, lie in parallel planes. A right cylinder will have a segment joining the center of the basis that is perpendicular to the basis. If I have the center of my second base, I draw a segment, this is going to be perpendicular. And I can find the area, or the surface area of a cylinder, once again using nets, or I can simply use the equation from before, tells me that the surface area of a cylinder is equal to 2 times the area of the base, capital B, plus the circumference times h. So if we look here, we know that this length is the same as this circumference, and that's why it's 2 pi r. So now we're going to find the surface area of the right cylinder shown here. Well, what am I looking for? I'm looking for the surface area. And I know that I find that using the formula 2 times the area of the base plus circumference times h. And I know that the area of the base is going to be pi r squared, and that my circumference is 2 pi r. For this particular figure, my radius is going to equal 4 meters, and my height is going to equal 5 meters. So all I'm going to do is substitute these values into my original equation. Simplify it and leave it in absolute terms of pi. And once I have my absolute value in terms of pi, I'm going to put it into my calculator to get my approximate value. And it's 226.2 meters squared. So again, looking for a surface area, so my units are going to be square units. Now you need to find the surface area of a right cylinder with height 9 centimeters and radius 6 centimeters. Round your answer to 2 decimal places. So make sure you follow the directions. It wants you to round to 2 decimal places. Hope you have a great evening, and I'll see you tomorrow.